I hope everybody got enough food and drink during the break, and lots of mingling was going on, so that's great. Are we all good at the back for video? Great. So we have a talk now about not only doing a CTF, but how to actually make one. I'm sure we're going to hear some mistakes that have been made and lessons learned. So as someone who doesn't have a ton of CTF experience, but very interested, looking forward to this talk. Thank you very much. Marit, Iren og Bendik Hagen.
Thank you.
Thank you.
All right. So I will stand here. Right. I have to find a nice spot, right? So we are here representing TGHAC. TGHAC is Norway's largest Jeopardy-style CTF. I will talk more about that later on. It didn't work, then yeah. I am Marit. I'm the leader of TGHAC. I also lead the hacking group at the University of Oslo called the UIO CTF. And when I don't do this volunteer stuff, I work as a developer at Sopra Steria. And in CTFs, I like mobile reversing, and I hope to get better at web security and PWN. PWN is binary exploitation. Bendik?
Yeah, my name is Bendik Hagen. I work as a security analyst at Mnemonic, and in TGHAC, I'm doing some infrastructure engineering and also creating some reverse engineering and forensics tasks.
All right, so we are part of a bigger crew. We host a large competition, so we are many people doing it. This is our crew this year. We are going to get even more people next year. There's a lot of stuff to do. This is the agenda for today. The main part is to talk about the technical challenges, right? But it's very important that everybody here knows what the CTF is and also what type of CTF TGHAC is. If we have time in the end, I will be doing a demo, a very simple web security demo. So, how many here knows what a CTF is? Yeah, oh, that's everyone. How many here has actually participated in a CTF? That's a lot of hands. Nice, real cool. Well, I'm going to get into details here either way in what CTFs are. I didn't actually think that so many people would have participated in a CTF. I have this nifty, I'm not sure why I said that, sweet and short definition of what a CTF is. And it is as following. CTF is a hacking competition with a wide spectrum of security-related tasks where the goal is to find a flag. And if you hadn't participated in a CTF, you would wonder what a flag is, and it looks like this. Now, we see that this is a little different than the one Kenny showed us, but this is a normal type of flag that we have in CTFs. We have this static part over here. In our competition this year, it said TG19 for every task we had. Then we have these nice curly brackets, and in between the curly brackets, we have a text that is unique for each task. Now, I like to say that these flags represent access you're not supposed to have, or information you're not supposed to see, or just something that recognize that you actually solved or you did the hack in a proper way. Yeah. So this is the most important parts of what a CTF is. And now I'm going to go a little further into details. CTF is short for Capture the Flag. It is a team-based competition. Usually all CTFs, you have teams for the CTFs. And it contains challenges from the security domain. There are two modes, attack and defense, and then the Jeopardy style. Since TGHAC is a Jeopardy style competition, that's what I'm going to talk further about. I'll just grab some water. Can I hold this? All right. So the name comes from this American TV show game called Jeopardy. And the reason is that we have several categories, and we have tasks within each category of different difficulties. The higher the difficulty, the higher the score. These are the most common categories in CTFs. We have the cryptography over here, some reverse engineering, binary exploitation, which is called pwn, forensics, and some web security. And then in the end, for all the tasks that doesn't really fit in any of these categories are put in the miscellaneous category. So there are two ways of giving scores to the tasks. We are using fixed scoring, which is not really the recommended way, since the scoring is supposed to represent the difficulty of the task. It's easier to use dynamic scoring, since dynamic scoring works that way that the more people who solves the task, the lesser points it gives you. So it's a nice way to visualize how hard the task really is. Right. So to play the game, you choose a task from the Jeopardy board. You solve the task. If you manage to, I guess a lot of people here has tried to solve some tasks that I didn't manage to. When you get the flag, you submit it. And when you submit the flag, you get points. It's real addictive. And to win, this is a dump from this year's competition. So to win, you have to either be the first team to solve all the tasks, or you have to be the team at the top of the high score list when the competition has ended. If two teams has the same score, the one that got the first wins. That's the rules of CTFs. Now, that was a short introduction about CTFs, and I want to talk a little bit about what's so special with TG Hack. To sum it up, I just told you that TG Hack is a Jeopardy-style competition, right? And I also said that we have fixed scoring, but that's kind of ironic because I said dynamic scoring is the recommended way. So we're moving on to dynamic scoring next year. And there was one more thing that I forgot, so we just move on. This is a picture from the gathering. It looks very nice, right? The thing is that it's an on-site competition at the gathering. The gathering is the huge LAN party in the Viking ship in Hamar. Next to being an on-site competition, we also host the CTF globally so that anyone in the world can participate. After the competition has ended, we have the site open so that people still can learn from our tasks. We have these two special categories, which are called AFK and Noob. AFK is short for away from keyboard, and those are all the tasks that are on site at the gathering. So you have to be in the Viking ship and maybe do some SQL injection with barcode scanners, or get a keyboard with Colmac, and you cannot, whatever. There's lots of very fun tasks to do in the ship. The noob category is something I'm very proud of, because this is where we've noticed that a lot of beginners want to participate, but the tasks are too hard. And we want to get as many people as possible to try hacking, try their best to learn about security and hacking. And so we make these tutorials so that people who cannot really solve the task can read the tutorial, and then they should be able to solve the noob tasks. Yeah, so the tutorials I just mentioned. We also have workshops at the gathering for on-site participants. And when the competition has ended, we have a walkthrough of the 15 most voted for tasks. after the competition has ended, we publish all source code, all write-ups, so that people can read the solutions for tasks. And we also, if we have time, publish templates so that other people can make CTFs as well. And this last point here, I'm very proud of. You heard Kenny talk about this CTF platform called CTFD. That's one of the most commonly used CTF platforms, but we make our own platform, and it looks really good. And yeah, this year, we had a little more than 1,300 competitors among 709 active teams. That was really cool. It was a very nice milestone for us. And there are two more things that I find very special with TG Hack. And it's that we have this focus on beginners. So we make all these guiding tasks for beginners, but we also make very interesting and learning tasks for the hackers with more experience. In addition, we have set this goal of becoming the de facto hacking platform in Norway, which it might actually seem like we're almost getting there, or might even be there now, as there are more people than I knew that seems to know about TG Hack, and we see a lot of people using it throughout the year. Yep, that's it. Oh, it's the first time I've been through this part so quickly. Then I can take it easy. So this is the main part of this presentation, the technical challenges that we've approached. We can separate these challenges into 4 parts. First of all, in order to make a CTF, we have to make tasks. We make approximately 40 to 50 tasks each year. And then we need to deploy these tasks, right? So we need some nice infrastructure and then some monitoring, which Bendik will be talking about today, infrastructure monitoring. So getting an idea might be the first part of writing a task, right? We get ideas from lots of places. We have lots of friends who know a lot of security. We read a lot of articles. There's tons of places, right? The next part is to really make the task. And we have these folder structures that has to be followed. This is one example of a task that has to be hosted on a server. So this is a PWN task called flip. Each task has its root folder inside the category folder. So this would be like PWN and then flip, and we have the root folder of the task. What we see in the top here is that we have a flag file. This file only contains the flag. And then we have the README file. This file contains the task description that the competitors will see, the amount of points, the author of the task. And these 2 files are very important to keep in the root folder, because as of now, we have not automated this part, and we have to put all the information into the CTF platform manually. That's tons of work, 50 tasks like that. Ugh. So we're going to automate this for next year to make it easier. Now, we also have this task.toml file. I will talk about that later on. And in the end, we have the file that I guess most of us use most time on, and it's writing the solutions for the tasks. Because we hope that people get to learn as much as possible from doing our hacking tasks. So from the top here, we have the server folder. In this folder, all the files that are needed to host the task on the server are put. No other files, which is really, really important, and I think Bendik will give an example later on. So in the source folder, the author can make his or her mess. It's just to be able to generate the task. And the uploads folder contains all the files that the competitor will need to solve the task. and that we put on the CTF platform. Oh, I forgot one thing. Of course, we use Git, and when we make a task, we branch out of the master branch. The master branch contains all the tasks that are ready to be deployed. And when you feel like your task is finished, you can make a pull request. And this is where our quality assurance comes into the picture. In this picture, the screenshot from GitHub, we see that we have a reverse engineering task, which is a kernel module. And what's going on here is that we have two reviewers. One of them is the category chief, the one that really knows reverse engineering. And then we have the volunteer. The volunteer is just someone who says, I have time, I can read the write-up, I can try to solve the task and go through, check, is it political correct? Does the task description match with the actual task? And can it be solved with the write-up? The category chief has to make sure that all the files needed to host it on a server are present and that the task may be solved. Nice. So when all the everything is in place, you can merge the task. Oh, there's no picture here. But since we're such a bunch of nerds, we don't just merge the task. We do this rebasing and squash and merge, all this Git stuff. All right. Deployment. Now, this is where the task.toml file gets into the picture. The task.toml file is just a file with key value pairs containing information such as what should the subdomain be called, what port should it run on, stuff like that. And then we have this, and now I'm going to quote the author of the script. We have this shitty Python script that runs through our repository, finds all of these task.toml files, and auto-generates or generates some Terraform and Ansible files. Now, Terraform is a tool that takes all of these auto-generated configuration files and builds the infrastructure, right? I have to ask him. He's the expert. And then Ansible, it builds the infrastructure, so it builds all these VMs. And then Ansible hosts all the tasks on these VMs. Yeah, I got it right. Nice. Now Bendik will be taking over and talk a little bit about more about the infrastructure.
Yeah, so I'm going more in depth on the infrastructure itself, because this is one of the main problems, is actually defending an attackable infrastructure where we have people actively trying to screw with our servers, basically. So for our infrastructure overview, as Marit said, we are trying to implement everything as infrastructure as code. We're trying actively to not do this tactic of hoping nobody hacks you. We try to do security in depth. So for this, we're using Google Compute Engine as our cloud provider and Terraform to deploy these cloud VMs. We're using Ansible to deploy the task itself that are Docker containerized. For our website, which is basically another infrastructure, is based on Kubernetes with Helm as a deployment manager. We're also using Traffic as a reverse proxy and Zabbix for our health monitoring. And last, we are using the Elastic Stack for logging. So yeah, we are using cloud pretty actively to deploy our infrastructure, and this is because it really helps us with the availability and scalability, so I don't need to drag my servers up to the Viking ship. And also I can request more resources for VMs or more IP addresses, whatever I need, pretty easily. And the only negative part mostly is the price, because there's no limit on the price. If you need 100 servers, it's going to cost. Another negative point about using cloud for CTF management is the complexity. And also you need to put some trust in the provider. But we didn't have any problems with Google this year, so I think we'll continue with that. So it's pretty important to firewall all the things, because we don't want people to pivot in our network. So we're segregating what we can. So as I said, the task infrastructure and website infrastructure are completely separated. So if someone managed to take control of one of the task VMs, they can't poke the website to change their score, for example. We're also kind of segregating the health monitoring and security monitoring. And also we're firewalling all things. No traffic should be allowed unless there's a firewall rule that says the traffic is allowed. And most of this firewalling is actually happening in the Terraform script that are deploying these Google firewall tags, basically. This year we hope that we could limit all the egress traffic from the task containers, but 2 of the tasks actually required some external traffic, so we didn't have full egress control this year, but we're hoping to get there next year to tighten everything down as much as possible. For management, all we do with management is out of bounds, we jump post. And next year we're looking into implementing more task-based rate limiting, as we observed with some of the web tasks, where some of the competitors started using some web brute forcers. And the web brute forces aren't actually the problem in itself, because we implement the tasks in a way that they shouldn't be solvable by using automated scripts, but they're creating a lot of noise and stealing resources from other competitors. So we're going to tighten that down next year. And for our host hardening, this is probably the most important part of our infrastructure, because we host some of the tasks which actually allows users or requires users to take control of the task and actually execute code. This is called RCE, remote code execution, and we separate all the tasks that are allows the users to execute their own code from the tasks that are not required to do that. So every RCE task is hosted on its separate VM, and all of the other tasks are hosted on multiple machines that are hosting multiple tasks. So if a user is able to pivot from but escape the container from one of the RC tasks, they should be able to get flags from the other hosted tasks. The containers are hardened somewhat. They should be running as an unprivileged user and with read-only files and no temporary files left, with the task part exposed to the world. And here is one of our failures for this year, because one of the tasks we deployed actually had one of the solution scripts in the temp folder, which someone found out really quickly and deleted it. So this is why we need to tighten down everything, because we have a lot of users that want to win. Also, one of the cloud host hardening we are doing is limiting the privilege the VMs can have towards the Google infrastructure itself, so the service account. So even if you're able to escape the container, you shouldn't be able to poke at our Google infrastructure itself. However, we still have some work to do, because if someone are able to execute code, they could use up a lot of resources and stop other people from actually solving the task by fork bombing or just using up all of the resources. So we're looking into using C groups to tighten this down for next year. As all of the tasks are also containerized, we might also look into hosting all of this with Kubernetes, but I think we will continue with our current setup for the next year. this is a picture from our website this year. It's really nice, and this is in the middle of the CTF, actually. The website itself is running as containers on Kubernetes, and as Marit said, this is homemade, which is why it looks really good, and we are really proud of this website. This year we peaked at around 100 requests a second, which is why we needed to scale up our backend to 8 containers, and we could probably keep on scaling if we needed to. This is actually the first year we opened up globally, so our CTF was actually on CTF time, which is why we received a lot more traffic than we are used to. So having a scalable infrastructure is really important when you are receiving more traffic than you planned on. However, we didn't have a high availability database this year, so we need to take this down for 5 minutes to scale it up this year. So this was the only downtime we had this year was the 5 minutes that the database needed to be scaled. We're also looking into implementing more caching and making the backend more efficient, so we're able to handle more traffic on fewer backend containers. And for the monitoring itself, this is really important when you have 1,000+ users poking around and trying all of the things they're learning from the internet. And that includes, of course, running random scripts that they don't know what they're doing. So I used Zabbix with DocBix, which is Dockerized Zabbix, to monitor the containers themselves. We're also using Google Health Stats on monitoring the cloud VMs themselves. And graphing this, I used Grafana. On the logging part, we used Google Stackdriver, which is actually really nice. And to get this into our own VM, which we could then use to further look into the logs, we used an event filter to take the logs from the Google Stackdriver into a message queue system called PubSub. And then we used PubSub beat to index this into Elastic, which ended up indexing around 1 gig an hour, which is a lot. But yeah, we're looking into implementing even more logging and monitoring next year, as a lot of the things we implemented this year was actually done manually because I didn't have time to set up a better system. We also used some cron jobs to restart some of the containers when we saw that users kept on deleting files from one of the failed tasks. And this is another nice reason for actually using containers, because they're pretty easy to just restart and everything works. So never underestimate the cron script. And also we're looking into next year using some kind of auto task solver, which then reads all of the solve scripts in the Git repository and then tries to solve all the tasks, and if it isn't solvable, restart the task itself. This is some of the statistics from this year's CTF. However, some of the metrics are not entirely correct because there was some weird aggregation going on. But at the top you can see we used the Google Health Monitoring itself to check our website, how quickly our website responded. So we actually had alerting if the website didn't respond quickly enough, so we could scale up the website. So our end goal is actually having one button push to deploy all of the infrastructure with the monitoring and security monitoring. So some future plans and lesson learned. Better time management. Don't do everything the following weeks before the competition. And more automation. This also helps with better time management, so we can focus on creating tasks rather than actually running our infrastructure. We also are looking into open sourcing of some of the CTF platform and some of the infrastructure code that we use, so other people can deploy similar CTFs. So, as a conclusion on some of the technical tasks, technical challenges, infrastructure as code is really nice. You can reuse it, and it makes infrastructure engineering really easy and helps with deployment. We actually ended up deploying all of the infrastructure the same day as the competition started. Containerization of tasks also helps this, as we are able to restart containers if anything goes wrong, and also helps with making sure that we don't need to install all the libs and stuff. Structure and quality assurance is important to make sure that you don't leave files in temp, and in general make the tasks solvable. And also never trust users, especially in the CTF when they're trying all the new scripts. So try to resource all of the resources like network and CPU memory and stuff with C groups. That's it for my part. Our infrastructure is still running in a somewhat limited state because we scaled down to save some money. But it's going to be up until January next year.
Yeah, 1st of January. So we do have time for the demo. Now, since everyone here has actually participated in the CTF, or almost everyone, then the task we were going to use is probably very easy. But we'll go through it either way. Maybe we can do it together. Yeah, let's do it together. Or we have so many people here, it probably will be too easy either way. Let's see here. So this is the web page, tghack.no. Oh, yeah. And I made this test user, and this is how it looks, our web page, when you get all the categories. So the task I was going to go through is this one. Let's see here. What's it called? It's magic. So the theme for this year was the Wizardry World School of Wizardry, right? So all the tasks had something to do with wizardry. And here we see the task description, and it says like, hey, did you remember to check your grades at It's Magic? So we can open up this link and check out the page. So this is how it looks like. Yeah, it's a reference. I'm not really sure if it's okay, but whatever. Yeah. So the first part, I'll just skip this one. It's not an SQL injection. We just do whatever. Apparently, I've done some stuff here. And we log in. And this is how it looks. So it's just to get like a feel of that. You have a user, you're going to log in. Now, do any one of you have a feeling of what it is? I know that someone already do. Huh? Yeah, ID, yeah. No, I hope that went well. So what would you do then? All right, what do you want to change it to? All right, 3037. All right, I won't do that at first. You're totally right. So basically, the thing here is it's a vulnerability which is in the OWASP top 10, which is called insecure direct object reference. I will go back here just to show you that. Oh wait, is the time? No, all right. It's the time here that is wrong. So it says like, are you stuck? Well, check out this. So I say Google insecure direct object reference, and also, have you ever heard about LeetSpeak? So when you check out insecure direct object reference, you see that you're supposed to have IDs that you cannot increment, right? should have random generated IDs. That's what I'm looking for. So what people usually do is like the first user or one of the first user in the system probably is the admin user, right? So whenever I get the task like this, I would probably just go to number 1, but then we just get the same page. It's different grades, but then we'll do as that guy over there, Vetle, said, and we get the flag. So this is one of the easier tasks that we have. I just find it easier to go through here. Nice. And then let's take the flag, copy it, put it into the CTF platform down here. And you solve the task. Woo! Nice. So that's how it goes. You are more than welcome to go into our page, register a user, and try to check out our tasks. We have lots of different tasks in different categories, so and we'll, as Bendik said, we'll keep the page open for a while. I think that's it. We did go through it a little quickly, actually. We could do another task.
Or does anyone have any questions so far? Okay.
Quick question. Have you sort of considered doing monitoring of the participants and how they execute the tasks, so that you can sort of, I guess, see what they've done to mess up whatever you have set up? Like, did that make sense? No.
It would be interesting, but at the same time, we need to ask the users for information.
Of course,
yeah. But it would be nice to, like, for learning purposes, I guess, to follow that. So we might look into it.
Because I guess running a task like this is almost like a capture the flag exercise in and of itself, keeping everything up.
Oh yeah.
I want to say something about that as well. We have actually talked about trying to filter out some input and check how many curse words we get. I guess there's a lot. Any other questions?
Anybody in the back? I'll start at the front.
Just a quick question. Is this interface currently freely available, or is it not open sourced yet?
It's not open sourced yet, but might be next year. Yeah.
Thank you.
When you guys are open source, are you going to start accepting donations? Because what you're doing is contributing to the community. So I guess we could also give back somehow, monetary.
I'm not sure about donations, but if you have any cool tasks you want to help out with, we might be able to open up for that instead, maybe. For now, at least, TG is paying for the infrastructure.
Did someone at the back have a question as well? Oh, okay.
What were the running expenses during TG, and what are the running expenses, say, this month?
I think it's 2,500-ish. So it's not that bad. For the rest of the year, I'm not sure, but we're moving the infrastructure actually away from the cloud to some of the TG or Can-Do servers to save cash, as we don't need to scale as much now.
Have you guys heard of, or have you participated in something like Boss of the SOC with Splunk? Do you kind of relate to, because that's something that's from like the opposite side. So this kind of also pings back to the question about logging what people are doing and kind of investigating that. Have you thought about kind of collaborating with those guys?
Not yet, but that would be interesting. So maybe. But yeah, we're also looking into logging more for our own infrastructure to keep our users safe.
This question is more related to that. I see this is in English, and you had it at then the gathering, which I presume is going to be all in Norwegian, and also considering the ages of the people who are at the gathering. How was this received amongst, and specifically, people in school, kids, students?
Well, most of the people that go to the gathering are there for gaming, and they know English. So and everyone can also come to the our spot, the TGAC area inside the ship, to get help. But we haven't really gotten any responses like that. Yeah.
All right, and it was a multi-part question. So the next part of the question is this. I know for a fact that several schools inside of Oslo, Kommune, Akershus, Ski, those kind of areas are working more and more towards introducing cybersecurity inside the school itself as one of the themes, as one of the subjects, and something that's taken forward. And it's gotten a sponsorship from the Kommune, from NSM, Internews also sponsored. Could this be toned down a bit? Because especially if I look at this challenge you've just done, it's a nice, simple, straightforward challenge. Kids can learn this, kids can do it, and it gets them started.
Definitely. We do have this tutorial page here, which is like anyone could go here. So you can make your kids, force your kids to do this. No, but if they would like to, we have like 3 tutorials here. So that even though if they don't know how to approach a task, if they don't feel comfortable with Googling, which we are trying to, we're trying to make people aware that you should Google this if you're unsure. Then you could, for instance, do scripting in Python. I really like this one. You can make your kids do some phone exploitation with Stack Overflows. So we have these text-based and tutorials so that you can see, for instance, how the stack looks, and it's explained. So definitely, we could use this, or anyone could use it for kids as well at schools.
Great. Any other? Yeah.
So have you already had any cases when somebody breaks in and messes up the infrastructure or something like that?
No. Do you want to say something, or can I? I will say something first. So last year, TG18. We did have an incident in the backend where someone did do the script tag alert thing. And I was just poking around, looking at the users, and then suddenly I got this alert, right? But I was so used to getting those alerts that I didn't really recognize it as a bad thing at first. And then I was like, oh, shit, no, this is actually a bad thing. But we patched it really quickly, and then no harm done. Yeah.
Yeah, for us, the other part of the question, I think would just, depending on where they are, how well they gotten foothold, would probably just redeploy some part of the infrastructure.
But if you just redeploy from scratch, it's still vulnerable. You don't change any code.
Oh yeah. Yeah, we'd have to look into our logs to check out what happened, I guess, and then patch it and redeploy it.
Anybody else? At the back again. Okay.
Or do you feel the need for any considerations for the participants' security? Because if you have kids, if you have people who are more inexperienced, is there any way that somebody could actually attack participant computers? Is that a consideration?
There is a possibility, yes, but we try to mitigate that as much as possible. We haven't had any problems with that yet. But it might be more cases because we are opening up to the world. So before we could go poke the guy who did it at the Viking ship, but it's worse if they're in the US or something now.
All right. Thank you very much, guys. Let's have a hand for Marit, Iren, or Bendik.